Hey, what you doing there?
Whoa. Who's there? I'm just playing with these Legos. They're like these robots and you can make them do stuff.
Looks like you're a great engineer.
What? Whoa, where'd you come from?
Engineers make things that make our lives better.
Like what types of things do engineers make?
Well, engineers help design and build your house, many parts of cars, trucks, or buses you may ride in, or even your bicycle, scooter, rollerblades, or skateboard are thanks to engineers.
So, if I want to be an engineer, I just have to build cars and bicycles? That doesn't sound like much fun.
No, there are many different types of engineering, like mechanical, biomedical, electrical, computer, and others.
I use computers, but what do computer engineers do?
Well, they helped build your computer. They were the ones who figured out how the keyboard would work, how the screen would look, what the mouse would be like, and how all the microchips and wires would connect together and make it do what you want it to.
What about those medical engineers?
Biomedical engineers make things that doctors use to keep people healthy, and they make other tools that surgeons use to keep people alive.
That's good.
It takes engineers a long time to do this, though. It's not usually a quick or easy process. To help them do their work, engineers use a lot of different scientific and mathematic tools.
Cool. That makes sense.
So, you do math, right?
Yep, all the time.
Right, and we use it all the time. But it's especially important for engineers. You know addition, subtraction, multiplication, and division? Engineers spend a lot of time working on very complicated operations and equations to get their jobs done. Science is a huge part of engineering also. This is all science. Physical and natural.
So why do engineers need math and science so much?
Well, there are a lot of different things mathematicians and scientists use that are also very helpful when engineering. There are certain terms and scientific laws that engineers have to know and work with when designing or building something. For example, friction.
Yeah, friction's like when things move past each other.
Or when they don't. See, something like friction is important for cars or Lego robots. The tires on a car or a Lego robot are especially made to have enough traction or friction so that the car can move when the driver wants to speed up and help it stop when the driver pushes the brakes. If there's no friction, the car can't go or stop. It's not very useful or safe. These are things that engineers keep in mind when solving different problems or making cars. They are also things you think about when making Lego robots. And none of that would even work if it wasn't for rotation. When objects rotate, they spin basically. When tires rotate, thanks to the engine or motor, they spin against the ground and there is enough friction that the rotation is able to move the car forward. When you're playing with Lego robots, the motors do the same thing. They make the tires spin and they can go forward.
Where does all the power or energy come from? All these things don't just work. Tires don't rotate on their own.
Exactly. All of this happens when there is a force.
A force?
When he pushes on the wall, he is exerting or making a force. When he kicks the box, it's the same thing. You see him make that force and it goes into those objects. The same thing happens in the car. When there is a force from the motor or engine, it pushes against the wheels so they can turn. And this is something called torque. When there is a force on something and it rotates, that's torque. Here's another way to look at it. We'll say these two weights are forces. Right now they're balanced.
They're the same, so it doesn't move.
Right, like when he pushed on the wall. The forces were equal and pushing against each other, so nothing happened. But when we take one away, that forces the bar to spin. Torque. And all of this is only helpful if we can use it in our lives. And we can. It's very useful when all of this can happen at a certain speed.
Oh, there's a speed limit on roads.
Yeah, usually we like things to happen really fast. We know the speed of something when we look at how much of something happens and how long it takes to happen.
Huh?
If you're in a car and you're going really slow, you don't have much speed. You aren't going very far and it takes a long time. But when you speed up, you go farther and it's really fast.
Right.
Right. So let's take one last look. In our example with the car, the engine is able to make a force so that the wheels rotate, a torque, and there's enough friction that the car can go.
That makes sense. I got it.
Engineers use all of these things and many more tools to work, not just making cars, but other transportation and games and buildings and homes. And it's what you use when you're doing something like Lego robots.
I'm gonna get back to engineering now.